Oh, I probably should have put this on first. All right. Chemistry 3.1. And I have to keep this under 15 minutes or YouTube's going to go crazy. So we're on our syllabus, Chemistry 3. And I think I might be able to cover all of this in one lesson. Gotta keep it under 15. So we're gonna cover that first. Here we go. Back to the other side. Boom. So they want to know the mass and the charge of protons, neutrons, and electrons. This is the basis of all chemistry. So easiest way to get it into the book is just to make a table. And there you go. The proton has a mass of 1. There's no unit after it that we need to know about. It's an approximate mass. If you look at what the syllabus says, state the relative charge and approximate relative mass. Sorry, it's relative approximate. So compared to everything else, it has a mass of 1. A neutron will have the exact same mass as a proton of 1. Electrons have a very small mass, but it's so small that we don't even count it, so it's 0. Now, a proton has a charge of +1. A neutron has a charge of 0. It is neutral. That's why, notice what neutral, right? That's why they're called neutrons. An electron has a charge of negative. Something that happens a lot, the students say that neutrons are negative because they both begin in N. No, electrons are negative. They should, if you remember them like that. Okay, and a neutron is neutral, and a proton is positive. Okay, positive, neutral, and negative. This is the basis of all chemistry. So now this opens up the door for the question, what the heck is a proton, a neutron, and an electron? So if you look at an atom, A-T-O-M, everything in our universe is made out of atoms. An atom is this, it's mostly empty space, but it's this small little structure that is made of 3 parts. It's made out of your protons, your neutrons, and your electrons. So an atom is made out of 3 parts: protons, neutrons, and electrons. Now, your protons and your neutrons live in the very center of the atom. So if you were looking at it from far away, it would be this circle, and right in the middle, there's this clump of stuff, and we're going to call that our nucleus. And the nucleus has this in it, our neutrons and our protons. And then flying all around the nucleus are electrons. They're whizzing around at the speed of, Superman. And they're moving so fast that they look solid. But actually it's just a bunch of electrons spinning around faster and faster and faster. Okay? A great analogy, not a great one, but one that I use is that the nucleus is like a dog poo. So that's your nucleus, and flies floating around it are the electrons. Okay? That's an atom. So an atom is this thing that's made up out of protons, neutrons, and electrons, but the protons and the neutrons are in the center, and the electrons are floating all around the outside. Done. So that should explain our protons, neutrons, and electrons and what we're talking about and where we get them. Now, inside of our nucleus, which is made out of protons and neutrons, we can use what we see to determine lots of stuff about the atom. So if we count all the protons inside the nucleus, 1, 2, 3, 4, 5, we now have our proton number. And if we count everything inside the nucleus, 1, 2, 3, 4, 5, 6, 7, 8, we now have what's called our nucleon number. Okay? In middle school, you might have learned things like atomic number and atomic mass. Pretty much the same thing, but different wording. The reason why they call it the nucleon number, if you lived in Bermuda, you are Bermudian. If you live in the nucleus, you are nucleon. So make sure you understand that. When you count just the protons inside of the nucleus, you get your proton number. If you count everything in the nucleus, you get your nucleon number. And the savvy kids will realize that if you take your nucleon number and subtract your proton number, you get the number of neutrons. So your nucleon number in this case is 8. Subtract the proton number, which is 5, and now we know how many neutrons we have. Okay? So not really a formula, but it is the basis of all chemistry. So make sure you understand that. If you're not sure, rewind, play again. We can take the number of protons that every element has, or every atom has, and we can now create a table with them. The reason why is that every element has a different number of protons. So if the element has 3 protons, it's lithium. If it has 4 protons, it's beryllium. Let's zoom in real quick. If it has 5 protons, it's boron. 6 protons is carbon. 7 is nitrogen. Okay, so each specific element has a specific amount of protons. The neutrons do not matter in this way, and the electrons do not matter in this way. If it has 5 protons and 1,000,000 electrons, it's still boron. It's boron with a lot of electrons, but it's still boron. Okay? So, quick note, I'm not writing it on the board, it's being said. Each element has a specific amount of protons. Now, when you look at this periodic table, and I'm using the one that Cambridge gives you on the back of the exam, people like to make theirs different colors and label it and all that type of stuff, but the reason why I use the Cambridge one is because they put their numbers upside down to mess with you, and we have to make sure we know what's going on. So let's look at these squares. All right, let's look at boron. In middle school, you guys learned top number and bottom number. That makes no sense. Whatever the larger number is the nucleon number. That means everything in the nucleus. And whatever the smaller number is, has to be the proton number. There's no way this could be your nucleon number because your other number is bigger. So I don't understand the concept of upper and lower because different exams and different periodic tables put the numbers in different places. So the smallest number is the proton number. Think of it like a basket. One number tells you everything in the basket, and the other number, if one number tells you everything that's in the basket, and the other number tells you how many blue are in the basket, your total basket number can never be the small one. You never say there are 6 eggs in a dozen. Okay? So don't worry about top and bottom. It's the big number or the little number. Whatever the smallest number is has to be the proton number. Whether it's on top, on bottom, on the side, it doesn't matter. The small one's the proton, the big one's the nucleon. Alright? On the Cambridge, they actually tell you this, and you may not be able to see it. On the back of the exam, they give it to you. Mass, proton number. And instead of using the term nucleon number, they use atomic mass. That's for later on, but it's all the same thing. They give it to you. Once you know your proton number, the other number is the obvious one. Okay. So now to explain the layout of the periodic table. You'll notice that the proton number increases as you go across and across are called periods, down are called columns. The reason why the columns are grouped as they are is for something slightly different. So every time the number increases, we've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You need to know everything about 1 through 20. Okay? You won't be asked many questions about the rest of them. You need to know everything there is to know about 1 through 20. So, That's their proton numbers increasing. The reason why they're grouped according to the columns like this, in 1 and 2 and 3, is because of electron shells. And that's something that should, each shell, the electrons are separated into what's called shells. I don't know where I left off. So we're looking at an atom. And as you know, your atom has a nucleus and a bunch of electrons flying around. But all the electrons actually fly around on, let's call them like a track. And the first track can only hold 2 electrons. And if there are more than 2 electrons in this atom, they bump over to the next one. But this one can only hold 8, and the next one can only hold 8, etc., etc. So I like to teach it like about a theater. If you go on a field trip with your class and there are 12 students in your class, and the theater had seats where 2 fit in the first row, 8 fit in the 1, 2, 3, 4, 5, 6, 7, 8. 8 fit in the second row and 8 fit in the third row, and the teacher said you have to fill the first rows first. You know how this goes. 2 would sit in the first row, 8 would sit in the second row, and that leaves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2 to sit wherever they want in third row. That's how electron shells work. If there are 12 electrons in this atom, 2 go in the first shell, 8 go in the second shell, and then 2 go in the third shell. So their electron structure would be 2, 8, 2. We're not on the structure, I just want to talk about shells. So to make life very easy, they've arranged the periodic table according to how many electrons are in the outer shell. And the outer shell is the last one. So this atom would have 2 in its outer shell, so I can guarantee you it will be somewhere in here. Anything with 2 in its outer shell goes there. Anything with 1 in its outer shell goes there. Anything with 3, oh look, they labeled it for me. 3, 4, 5, 6, 7, 8. The last one's called 0 because if you notice, the 2 and the 10, the outer shell has to be full. It doesn't matter how many, because your first shell can have 2 in it, you can't call it group 2 because one that already exists. You can't call it group 8 because you can have 2 in your outer shell. So they just call it group 0. Okay? Don't call it group 8. They stopped saying that like 5 years ago. Now, we're talking about electrons. How do you know how many electrons are in an atom? And the answer is quite simple. Atoms have no charge. So if an atom has no charge, then the amount of positives that the atom has, and we know those are called protons, has to equal the amount of negatives that the atom has, and we know those are called electrons. So let's look back at fluorine, for example. Let's look at this one. Fluorine has proton number of 9, which means that it has 9 positive charges. So 1, 2, 3, 4, 5, 6, 7, 8, 9. In order for this to have an overall charge of 0, so no charge, it also needs to have 1, 2, 3, 6, 7, 8, 9. It also has to have 9 electrons. And you know, positive plus a negative cancels each other out, I'm not going to do this for all time. So if atoms have no charge, then we know that in an atom, only in an atom, protons equals electrons. If I have 6 protons, I have 6 electrons. If I have 9 protons, I have 9 electrons. But what if you have 23 protons? Well, then you have 23 electrons. And I understood too. Please note, I'm not talking about neutrons. Nobody cares about neutrons. All we care about is positive and negative. Who cares about 0? Well, actually, we're going to talk about 0 next. Now, remember we were talking about shells before. So let's deal with something that has 1 in the outer shell. So something that's in group 1, let's take a peek at what we can see. One more. Group 1, let's look at lithium. Proton number of 3. Okay, so lithium has a proton number of 3. Oh, why didn't I look at the other number? It doesn't matter. Alright, which means it also has 3 electrons. Now, every element is jealous of group 0. Everybody wants to be group 0. They're the cool kids on the block. The reason why the cool kids have a full outer shell. They have no want, they have no need. Every atom wants to have a full outer shell. So lithium has 3 electrons, so we'll draw its nucleus. In the first shell, lithium must have 2, E. And in that second shell, it has 1. Now lithium wants to be full. It wants a full outer shell. So it has 2 options. It can gain 7 electrons, or it can lose that 1 electron. Both of those would make him happy, or her happy, whichever one. And every element wants to reach the status of full outer shell, so that they can become noble gases. Okay? So, they'll do whatever they can. They'll get rid of electrons, they'll steal electrons, they'll share electrons. They don't care. They just want to have their outer shell to be full. And then they're happy. A special name is given to this electron in the outer shell. They like to call it the valency electron. And it's because that electron determines the valency number. We won't cover valency numbers in this topic, but we will get to it. But you need to know that that outer shell electron is known as the valency electron, and that every atom wants to have a full outer shell. So what I need you to do is pop back to your syllabus, because I've jumped all over the place for this one. We covered this, states of relative charges, yes, we did that. Proton number and nucleon number, check. Proton number and the simple structure of atoms between the bases, check. I skipped all the isotope stuff. I'm going to do that as a separate video, and then I went on to this. Describe the buildup of electrons in shells, yes. All right, so that's chemistry 3.1. A is going to be a 3.1B soon.